there is an alternate way to represent functions in algebra, and you've probably seen this before. An example of this, instead of, for example, this problem I used in the last video, y equals x cubed minus 9x, we can write this as f of x equals to x cubed minus 9x. So this looks like it's letter f times letter x, but that's not what that is. If you wanted f times x, you would just write fx without the parentheses in it. But when you have a letter, or sometimes even a name, parentheses, and then at least one variable in there, then that typically represents a function. And we read this f of x is how this is typically read. So one thing you learn about this function notation is that y and f of x mean the same thing, at least in the context of our course. Now, you take a lot more math, you'll have functions of all kinds of variables, and but in our course we pretty much stick to this. Y as a function of x, they're interchangeable. So think of this as a y value. This notation is pretty handy for representing things. And so, for example, up here, if we wanted to ask the question, what is y when x is 2? All right. Well, to answer that question, we could say, what is f at 2? F at 2 would be 2 cubed minus 9 times 2. And that ends up being what? 8 minus 18, which is negative 10. So f at 2 is negative 10. And that's the y value when x equals to 2. So actually this notation, it turns out in some cases it's handier to use than the y notation, as it turns out. There's a very big calculation in calculus which looks like this: f of x plus h minus f of x over h. And when you let letter h shrink down to nothing, shrink down to 0, this calculation is called the derivative. It is the foundation of differential calculus. So here we have two functions, f of x plus h and f of x. Well, what would f of x plus h mean? It means your input has changed to x plus h. So I'll give you a quick example of that, because we can work not with just ordinary numbers. We can work with symbols with this notation. So, for example, what if you have a function f of x equals to x squared minus 3x plus 4? And so it's possible to ask this question, for example, what is f of x plus h, like I mentioned down here. Okay, so that means take this and replace the x's with it. So this becomes x plus h squared minus 3 times x plus h plus 4. And then you can go from there. This can be simplified. And but that wasn't my purpose, was to simplify that. It's just I wanted to show you that this notation is pretty flexible. That we can look at numbers being inputted. We can look at letters being inputted, or combinations of all that. And we can change our letter. We can have functions that use different letters, like g of x, or here's one I use in finite math a lot. Capital C of x represents cost based upon the input value of x. So by and large, the letter in front of the x, or the parentheses, is the name of the function. And if you're just working generically, then in algebra, f and g seems to be the functions of choice. Just like we like to use x and y, f and g are typically what's used. But you can call a function anything. If you, for example, had an area function, you might use a of x. Or volume might be v of x. And so you can name these things. So that letter or name is the name of the function. What's in the parentheses is the input variable. And the input variable, we're mostly going to use x, but you could could get broader with this and use any, define a function in terms of any variable. So it's a very flexible notation, and one that you'll see from now on, and not only this course, but if you take more math, it will just continue to see the function notation. So that's about all there is to say about the notation aspects of it. But you should learn how to recognize these things.